Hey, welcome everybody. It is my pleasure to welcome you at Pearson blog. We will have 90 minutes from our Platinum sponsor. Pearson was kind enough to be supporting the WIRE conferences for the 5th year in a row. And that's a huge financial help. So thank you for that. Today we will have the first talk by Kacper Łodzikowski, who will talk about AI learning capabilities. Kacper recently changed his position and now he's a vice president of AI learning capabilities. For those who doesn't know, Pearson has an office in Poznań, Poland, and that's a very advanced analytical company. And they're doing a lot of machine learning and artificial intelligence products. So it's, in my opinion, going to be a very interesting talk. And a few words about Kacper. He leads the AI learning capabilities unit at Pearson. He's also a researcher in second language acquisition and a lecturer in AI R&D management at the Adam Mickiewicz University in Poznań. Kacper is known as an avid user of R for his academic work. So thank you for joining, Kacper, and I hope we'll have a fruitful discussion after your presentation. So I'm just leaving the floor for you, and good luck with your talk.
Thanks, Marcin. I'm excited to be here, and let me just say that we've attended this conference since day one, and we gave so many talks over the year, but we also learned so much over the years. So just wanted to thank you first and Michał for maintaining the momentum. I really appreciate the work you're doing for both the R community internationally and also with the grants for the data science, women in data science community in Poland. So thanks so much. Today we have a 90-minute session and 3 talks. And I'll first start with just a high-level overview of the opportunities and challenges of using AI in education. I'll give 1 or 2 examples, depending on how much time we get, regarding unstructured data. I'll focus on English language assessment the most. Maybe I'll give an example about math assessment as well. And then I'll briefly just mention some ethical considerations. Then we'll have 2 tech talks that will build on the examples that I will give. One will be about the science of data annotation, including unstructured data for English language assessment. And the 3rd talk will really dive deep into some of the methods about latent semantic analysis that I will mention in my talk. And in the YouTube chat, you also have members of my team already. So if you have any questions, you can probably post them already. Just wanted to start by telling you more about why you should be paying more attention to what's happening in education regarding AI. As we are embarking on this 4th industrial revolution with the boundaries between the physical worlds and the digital worlds becoming fused together, with all the advances in 5G, AI, genetic engineering, and so on, the world is changing real fast, and learning is more important than ever. And this is really what we do at Pearson when it comes to the products and services that we build. We help people to thrive in this new developing economy. The global learning market is quite big today. It's about $7 trillion, and it's projected to grow to over $10 trillion by 2030. And there are 3 interesting things if you look at this chart. First, 75% of the market is formal education. That's primary, secondary, and tertiary. There's a growing market for lifelong learning and informal learning that is driven by the growth in the middle class and longer careers. And it is possible that some of your friends or family or you will reskill over the next 8 years, because it's estimated that within the next 8 years, around 1/3 of the world's workforce will need to transition because of such advances as AI. So this is a big emerging market. And the 3rd thing to notice here is that this market is really big, but only 3% of that is digital. So there's a lot more we can do to scale education, to make it more affordable and accessible. And all this means that it's really an exciting opportunity for companies like Pearson to innovate around digital products. And just in a couple of words, this is what Pearson does. We are the global experts in learning. over 20,000 employees in 200 countries. Each year, we help millions of learners. And our business is all organized in these 5 divisions. I'll just give you examples today from the English language learning division, which you may be most familiar with, because if you have kids at school, they probably learn from Pearson products. And you may also be familiar with this division. If you ever took an AWS certification as a developer, architect, or DevOps, then you probably took one of our assessments as well. But the examples that I'll give around unstructured data will come from this particular division. And just a couple of words around about our team. It's a team based in Poznań, about 25 people, and we really specialize in what we call intelligent learning capabilities or AI learning capabilities. And by that, we mean systems that use methods from the field of machine learning to advance human learning. And we really specialize in these 2 fields, psychometric modeling, often sort of existing psychometric ideas, trusted psychometric ideas, but implemented using new machine learning methods, such as an adaptive diagnostic assessment that identifies your strengths and weaknesses so that you don't have to take an entire semester of learning, but maybe you can progress faster, or maybe you need some remediation if you struggle with something that you covered previously in high school. And another specialization or niche is natural language processing. I'll focus in this talk on this particular bit because psychometric modeling, we've talked about it a lot, even at this conference previously. And we've documented all of this on our website. So I encourage you to go to this website. And today, this talk and the following 2 talks will focus on NLP, which we specialize in as well. Before I talk about technology, though, I wanted to discuss just one assumption about learning that has prevented many people before from fully leveraging the advances such as AI. And that's the notion of the inferential distance. Because assessment, really, learning is about assessment. And assessment is about making claims. And you as data people are familiar about inference and making claims from data. And this is really what learning is. There are things we can measure easily, and there are things that we actually want to measure. And the length of the logical chain to get from the observation to the claim you want to make, that's the inferential distance. And most of our education is based on these close-ended assessments, such as multiple choice questions. That's easy to design, that scales well, but it doesn't give you actually often enough evidence about what happens in the real world. And you wouldn't grant someone a driving license after they've passed a multiple choice question. You actually require them to take a skills test. And maybe in the future, we will put more cameras and GPS in people. Maybe we'll use simulations to just go even a step further so that it's not just a 30-minute driving test. Maybe it's longer, maybe it's over a couple of days, for example. So if we take a learning situation, again, this is what you can measure easily, but the inferential distance is pretty long. And a close-ended multiple choice question like that is not, that doesn't generate anything apart from whether the answer was correct or incorrect. That doesn't tell us anything about what really happens when people make assessments and make claims about each other in social context or other situations. And one example I'll give you that you're familiar with, if the teacher asks a student in the classroom to solve a piece of homework or solve a math problem in front of the class, the teacher will know, even before they approach the student, whether that student is bored, whether they struggle, even before they look at the piece of paper and whether the answer is actually correct or incorrect. Similar here, once the student approaches the whiteboard, the teacher will know based on observation, based on how the student performs each particular step, even before they reach the final answer, whether that answer will be correct or incorrect. And that's assessment in real life. So the inferential distance is pretty small. If you have kids and you help your kids with homework, you are making some claims about your kids as to what that child knows or doesn't know. At a job interview, similarly, the interviewer is making some claims about the candidate based on their performance, and the other way around. In fact, right now you are making some claims about me, some assessment based on how I'm dressed, what's my background at my home office. That's all assessment in real life. So in the space that I wanted to focus on, language assessments, there are advantages and disadvantages of using humans. Obviously, humans are pretty good, like we said, at generally using language, getting sense of social situations. For language assessment, humans get the pragmatics, such as humor and irony, which machines don't. And also they are tuned to various types of errors, such as if I make an error, if I self-correct, if I misspell something or I mispronounce something, and then I self-correct, then you will know that it's not. It was a careless error. It wasn't a fossilized error. But there are also disadvantages to humans. Availability of teachers around the world, that's a big problem. The cost, especially when you want to hire a one-to-one tutor, the speed and energy with which humans assess others, and then there's the bias and inconsistency. So if all of you have one time or another taken a course in English, maybe an exam like Matura in English, and you know that there's always something about humans, human assessors or teachers are always distracted by something, maybe your personality or your body language or how you're dressed. And they also transfer their judgments. Maybe if you misspelled something a couple of times, then maybe that they will transfer that judgment into your speaking skills, even there's no way for you to misspell something in speaking. So I wanted to give you one example of how Pearson has over the years built its automated language assessment pipeline. That's a technological pipeline used in a variety of products, both for spoken and written language assessment, not only for English, also for other languages. And it's 25 years of R&D. In fact, the first company was founded by two Stanford professors that Pearson then acquired it in. And since 1996, overall, that system scored more than 350 million assessments. And overall, the assessments are trusted by governments worldwide, universities, companies, the military, everywhere where you go. You'll probably encounter one or other Pearson test for English. And one example I wanted to discuss today that you may be familiar with, especially if you travel to Australia or the UK or New Zealand to study or to work, you will need to take that test because the governments of those countries require you to take it because they trust it. PTE was the first entirely computer-based test, which ensures it's bias-free, and I'll show you how in a second. It's pretty complex assessment of 4 skills, and you get the results within 48 hours usually. It's a pretty complex scoring pipeline that's automated and a pretty high volume testing environment, but I think the results are pretty impressive. I'll give you an example first of how, what's different about how Pearson assessments, evaluate someone versus the traditional multiple choice questions. And just to preface, this is group work by many colleagues across the company over the past years. So just to give you a taste for the methods rather than the products that we work on. What we do first is, we decide whether, we decide what we define what we want to measure, which aspects of language we want to measure. And then we design activities to elicit the performance of that evidence. And this is one particular activity. You have to look at a graph and then for 25 seconds, for 40 seconds, speak, just describe the graph. It's a productive activity. There's nothing to click here. You just speak, you just describe what's in it. And you're being scored on a couple of traits. And that's the second step in designing such a system. You have to design so-called scoring rubrics for the things you want to measure. And the things you want to measure, we call them traits. So in this particular task, the content is whether you describe the graph correctly. And then pronunciation is how you pronounce all the vowels, consonants, and so on. And fluency is whether you spoke smoothly, without any hesitations, and so on. And the key here is to design these rubrics because we will have humans who will rate speech responses from actual learners according to these traits. So in this particular example, describe a graph, we just have three traits. And then the next step is to ensure that you have enough activities from a given example, from a given type, to inform a given trait. So the example that I showed, describe image, you have 6 activities like that in a test, but you also have other types of activities, such as you listen to a lecture and then you have to retell it, or you listen to a sentence and you have to retell it, and so on. And all of these inform these traits. So it's not just like a one-to-one scoring like in a multiple choice question. The third point, once you define what you want to measure and you design the scoring rubrics, then you have to, if you have the data, label it. And what you do is you hire expert, for speech, you first hire expert linguists to transcribe the speech, because what we do is we score the transcribed speech first for content, so that, and this is really important, so that how you pronounce something or how you delivered the content, so that is not scored. The content, what you said, that is scored. And then the speech, so the pronunciation and the fluency, that's rated separately, that's labeled separately as well. So what you do is you take the data, you have the raters, these are expert raters, teachers, linguists, you train them, you calibrate them, you make sure they are in agreement with each other, and then you give them a couple of hundred of responses to actually measure their reliability. Because what we want to happen is, we don't want to have a situation where you have 2 raters and the third rater saying that person disagrees. You don't want to have noise in your labels, because then that noise will translate into the models. So if we have raters who we see that they don't really agree with the larger group, then they are excluded from the group. And this is how we ensure that how people judge a given response is reliable. Then you proceed to building the models. If you have enough data, and we would usually require about 500 responses for a given activity. If you have the previously mentioned human scores for that, then you build models. And depending on what you want to score, for the described graph tasks, we're scoring content. And Mateusz will talk about a couple of methods as how we do it in the separate talk after me. So usually look at the how semantically similar a given learner response is to previously assessed responses. For pronunciation, you usually build an automated model that translates graphemes to phonemes and then matches what the person has said to the sort of ideal pronunciation. And then fluency is, you could measure it in a number of ways: hesitations, interword silence, a couple of different measures. What you then do is you take some data that the model hasn't seen, just like in any machine learning situation, and then you give that data both to the humans and to the machines. And usually, again, it's like about 500 responses, and then you calculate the human to machine correlation. And usually, for the test that I described, for the PTE academic test, that correlation is very, very high. In fact, the difference between the human score and the machine score is so small that it is usually less than the difference between 2 human raters. So this is what really ensures the reliability of the test and the fairness of the test. And then if you want to build filters on top of that, for example, if you want to make sure you don't score any noise, or if someone submits a recording of silence instead of speech, you want to make sure that doesn't get somehow scored. And then for cheating, we also have other methods of ensuring that. If you want to score writing, and that's an example written activity, so you have to write an essay that's 200 to 300 words. You get a prompt, say about tobacco, and then you get a question, and you have to write an essay of about 300 words. The process is actually really similar to what I just described for speech. So you get rubrics so that people agree on what they are scoring. For PT Academic, for writing, the corpus was 50,000 responses to different types of essays. The traits are different. There's no speech, so you focus more on content, so grammar, spelling, and so on. And the types of models and the weights of the models are different. We're talking about large essays, that's 300 words. So obviously, methods such as latent semantic analysis for the semantic scoring, that's more important than in speaking. And obviously, validation is also a step here. And in this case, the state of the art on our side is close to 0.9, which again is more than human to human correlation. And let me just say a couple of words about the question that you may get, because it is possible that you or your family or friends or your kids will take a test like that in the future, and then you'll wonder, well, how can AI ensure that this is ethical? And usually for an assessment, we would ask these three questions. Do we measure what we are supposed to be measuring? Will we make the right inferences, the right claims about members of different groups, so from different language backgrounds or social backgrounds? And then are the results consistent over different testing occasions? And in all of these cases, if you look at that particular test, the PT Academic test, the answer is yes. Because we make sure that we separate in the spoken response, for example, the speech from the text, so that what you said is not scored based on how you said it. We make sure the raters are trained and score consistently. So essentially, it's an AI system, but it is essentially, there is a human in the loop in there, very much involved. So the question would be, I could turn the question around and say, if it's a well-designed assessment, does it matter if it's a black box model? If we see that it performs well, if we see the rating is consistent? And just to give you another example of that final situation, reliability, there was a situation once where someone, one test taker of the PT Academic test, took the test close to 40 times within 4 days. And over those 40 attempts, not sure why they did it, but they did it. They got pretty much the same score, which is exactly what we want. Because if you would have the human score 40 tests from the same person over 4 days, guaranteed they would score it differently. Other considerations, some of these models are black box, but we're really, as Pearson, make sure that we promote the explainability. And we even if people cannot always understand how the models work, we try to just explain how they work. In this type of in this line of work, there are some limitations about the data you can get to train the models. You can't always get all the data you want, and sometimes also it's because of privacy. So we are working unstructured text and spoken data sets where you could get personally identifiable information. It's not as easy to work with it. And then finally, if you're ever in doubt, just like in our case, there's probably there's probably a framework for ethical AI in your sector. There is one for education that Pearson actually co-sponsored. So I suggest you base your best judgment on that. And just a final quick comment before we go, as a bonus for those who specialize in maybe in computer vision, the same thing applies. The inferential distance in assessment applies to other disciplines. And this is an example activity from Matura. You have to complete a complex calculation, and the answer is a fixed. It's a close-ended answer. But then what you actually want to measure are the steps. And Pearson has a product around that does handwritten math recognition, and then scores a particular step and then gives you feedback on the step. It doesn't tell you whether the answer was correct or not. Just it gives you feedback on the step. And one problem, and I've linked, provided links here if you want to learn more about it, because I'm just mentioning it briefly. One nice problem about this product was that the off-the-shelf OCR models don't well work with math, especially if you use different types of papers, different types of pens, and so on. So what the team did last year and over the past 2 years is that they collected some data first, and then they synthetically generate more data to train the models. If you look at this, some of these examples are generated, some of these are real. These, with the green box, these are real examples. Everything else, what you see, is synthetically generated. And we within hours can generate millions of such examples, simulating various types of strokes, various types of pens, of papers, and so on. And that is the data that we use to train the models, not least because that data is hard to get, because that's really peculiar, niche stuff, unstructured data. So there's a data set that we published on Kaggle if you want to learn more about this entire project. That's the synthetic data set. It's a nice toy data set for training models. And just to remind you, if you'd like to learn more about our work, have a go, click, and thank you all for taking the time to attend this conference again. Thanks again to Marcin and Michał for organizing it.
Hey, Kacper, thanks for the talk. That's both fascinating and frightening how much AI can do. Maybe just a couple of quick questions before we start another talk. Do you attend classes with students to see real learning process in the real life? Do you need any pedagogical education to work in your team?
Oh, that's a good question. So my team is a part of a larger unit called Efficacy in Learning that specifically specializes in designing learning and designing assessment. So we have 3 different teams, and you can read more about the team online. We have a team that defines specialists in learning design that define what we want to measure, how the pedagogical process should look like. They make sure that whatever we build is centered around the learner. They also work a lot in the field, and they also conduct a lot of research just to understand how products should be built, not least based on how humans learn cognitively and how the learning process looks like, because it differs per discipline. And then we have people who build this stuff like my team, and then people who actually conduct rigorous studies, similar in a way to how medical companies would test drugs, where you give, where you rigorously, usually over the course of, say, a semester or a year, observe how people use a product, sometimes 2 products compared together, just to be able to say, really, that the claims that we're making about a product, that it helps people learn, these are valid claims. So Pearson has been doing a lot over the past, I would say, 10 years, to focus on the efficacy of products. That's really a big focus, big deal.
Thanks for the reply, Kacper. I see that the other stream already started, so maybe just one last question. How many spoken languages you need to deal with when working with your data? Is everything in English, or do you need to translate it, or that doesn't really matter in your case?
So my team specifically works with English. The test that I described, the PTE test, that's also available in several other languages, Arabic, Spanish, for example. So, but the pipeline, the most important thing is the ML pipeline for labeling data and then scoring, because this is what really allows you to adjust the pipeline pretty much to any language you want, depending on where you want to offer the tests. Because like I said, the need for those tests is bigger in some markets, for example, New Zealand, Australia, UK, than others.
Okay, Kacper. Thanks again for your talk. And there is a couple more questions on the chat, but maybe you can just reply offline.
Right.
And let's just skip to another talk. So once this is finished, you will all get redirected to the second talk by Isabella, and we will be talking about the science of data annotations. So thanks, Kacper, once again, and see you on a